This is a problem of permutation and combination. Here we have a lock consisting of 3 rings, each of which is marked with 15 different letters. It's If we draw a diagram, if this is a lock, there are 3 rings and each ring has 15 marked letters. It is found that Vijay could open the lock only after making half the maximum number of possible unsuccessful attempts. An attempt is defined as a number of 3 letters on 3 rings, 1 letter on each ring at a time to open the lock. If each attempt takes 10 minutes, then the time he must have spent on opening the lock is not less than. So first of all, we have to find the maximum possible number of attempts that one can make on this lock while trying to open it. As we know that there are 15 marked letters on each ring, so the number of attempts that will be there is 15 into 15 into 15. Since every ring has 15 letters and there are 3 rings, so the total number of attempts that can be made is 15 raised to power 3. As we know that one attempt must be there through which lock gets opened, so the number of unsuccessful attempt will be 15 raised to power 3 minus 1, and this is equal to 3374. As we know that the person succeeded in opening the lock after making half of the maximum number of possible unsuccessful attempts, so half of this will be 1 by 2, 3374. As we have to minimize the time, then we just need to consider the case when he made exactly half of the number of maximum possible unsuccessful attempts, and after that he got the lock opened. And it is also known that he takes 10 minutes in each attempt, so the total time that he needs to make sure that he opens the lock after making half of the maximum possible number of unsuccessful attempt is 1 by 2, 374 into 10. This is second. When we convert this quantity into hours, it will be around 4.68 hours. So the minimum time that he must have spent on opening the lock could not be less than 4.68 hours, which is option A.